Hi there. In this video, we're going to look at derivatives of a more complicated multivariable function. And in the process, we're going to revise the chain rule and the product rule. So let's start off with the chain rule. What the chain rule focuses on is finding the derivative of a function inside a function. If we have a function y, which is equal to sine of x squared, how do we find the derivative of this? What the chain rule says is that we have to think about it in terms of an inside function and an outside function. So the outside function is sine and the inside function is x squared. So the derivative of the outside function is the derivative of sine, which is cos, and we have to multiply this by the derivative of the inside function, which is the derivative of x squared, which is 2x. That's our answer. In terms of notation, what we do is we let a new variable, let's call it w, and we let that equal to the inside function, which is x squared. So what the chain rule says is that dy dx is equal to the derivative of y with respect to this new variable w multiplied by the derivative of w with respect to x. So if w is x squared, it means that y is the sine of w. So dy dw is equal to the cos of w, which is just the cos of x squared. And the derivative of w with respect to x is simply 2x. So applying this chain rule formula, dy dw is cos of x squared, and dw dx is 2x. So we can see how it is the same thing, but it's very simple and easy just to think about it in terms of an outside function and an inside function. Another example would be y is equal to e to the power x squared. So to find the derivative of this using the chain rule, we find the derivative of the outside, which is just e to the power x squared, and the derivative of the inside, which is just 2x. Okay, and that's our answer. One final example that we can look at is y is equal to e to the power sine x. As before, we find the derivative of the outside function, e to the power whatever is just e to the power whatever. So the derivative of e to the power sine x is just e to the power sine x as the outside function. We multiply this by the derivative of the inside function, which is the derivative of sine, and that is cos x. Okay, and that's our answer. So now we can move on to the product rule. So what does the product rule say? The product rule says that if we have a function that is the product of u, which is a function of x, multiplied by v as a function of x, then dy dx is equal to u times dv dx plus v du dx. An example would be y is equal to x squared sine x. So this would be u, and that would be v. So we would let u equal x squared, and we would let v equal sine x. So du dx is equal to 2x, and dv dx is equal to cos x. Applying the chain rule, what we get is dy dx is equal to, firstly, u, and u is x squared, multiplied by dv dx, and dv dx is cos x. Added to this is v, which is sin x, multiplied by du dx, and du dx is just 2x. That's how we would find the derivative using the product rule. So now we will apply this in our multivariable example. We can take the multivariable function z is equal to e to the power sin x times cos of y. So let's start off with the derivative of z with respect to y. It's pretty much easy to do this because x is a more complicated looking function. Just as a reminder, if we have y is equal to kx cubed, where k is a constant, then dy dx is just equal to 3k x squared. So the k does not change inside this particular derivative. So if we're finding the derivative with respect to y, then e to the power sin x as a constant just remains as is. So day z, day y is equal to, firstly, the constant e to the power sin x multiplied by the derivative of cos y, and the derivative of cos is minus sine. So this is fairly straightforward. Now if we find the second derivative of this, we say day squared y, day x squared. This is equal to, again, this e to the power sin x does not change, it's the constant. And the derivative of sine is cos, and of course there's a minus in front. So that is the second derivative. So now we would move on to the derivative of z with respect to x. So day z, day x is equal to, firstly, cos y remains as is. We just write that down as the constant. And then this is being multiplied by the derivative of e to the power sin x. So using the chain rule, and we did this already, the derivative of e to the power sin x is simply the derivative of the outside function, e to the power sin x, multiplied by the derivative of the inside function, which is derivative of sine, which is just cos. Finding the second derivative, again, cos of y remains the same as it's a constant. We treat the other variables as constant. Now we need to find the derivative of e to the power sin x times cos x. So we can see that this is the product of two functions of x, so we need to use the product rule. So let's just remind ourselves what the product rule is. So it's u times dv dx plus v times du dx. In this case, u is equal to e to the power sin x, and du dx is equal to e to the power sin x cos x. V is equal to cos x. Therefore, dv dx is equal to minus sine x. Putting all of this into the equation, firstly, u is e to the power sin x, e to the power sin x, multiplied by dv dx, which is minus sine x, minus sine x, then we would add to this v. V is cos x, and du dx is e to the power sin x cos x. We're multiplying v by du dx. We see that there's a cos x here, and we're multiplying it by the cos x here. So this cos times this cos is going to give us cos squared. So we're going to be left with e to the power sine x multiplied by cos squared x. Okay, I'll just like to move this to the side to make it look a bit better. Okay, and that's our final answer. In terms of the mixed partials, we could find day z, day y, and then with respect to x, so day squared day z, day y, then taken with respect to x. So we're finding e to the power sine x times minus sine y, and then we're finding the derivative of this equation with respect to x. So what we're going to be left with is minus sine y, since it's treated as a constant, multiplied by e to the power sine x, which is just e to the power sine x times cos x. Then finding the derivative of day z, day x, now with respect to y, it'll be day z squared divided by day x taken with respect to y. So this is going to be the derivative of cos y with this kept constant. So the derivative of cos is minus sine, so we're left with minus sine y, and this is multiplied by the constant part, which is e to the power sine x times cos x. And we see that these two are equal. So we see that day squared z day x day y is equal to day squared z day y day x. So as a general rule, this is true. So in a test or an exam, it could be asked, show that the mixed partials are equal to each other. So what we would need to do is find the first partial derivative of z with respect to x, then take the second derivative of that with respect to y, which is what we've done here, and then do the same with day z, day y, find that first, and then take that with respect to x, and then find both of them, and if they are equal, then it means that your working was correct. Thank you very much. In the next video, we would look at function differentials.